same and is 0.35 log I. So that basically says logarithmic utility is an extremely good fit, at least to people's self-reported subjective well-being. Yeah, Connor?
Do you know what the survey question was? I thought I worded it.
Yeah, it says, on a ladder of life going from 0 being the worst life you can imagine yourself living to 10 being the best life you can imagine yourself living, where would you place yourself?
And then do you know if there was like unusual behavior at the top of this? I assume I picked the rest of this behavior, like the top 1 or 0.1 percentiles.
Well, you can sort of look. I mean, I think it's sort of getting cut off a little bit down here and clustering up there, but otherwise it's pretty similar. I mean, I don't think those people get sampled very much because they're a tiny part of the population, but okay. So I think that along with other evidence, which I don't have time to show you guys, is a pretty good reason to use logarithmic utility to represent people's preferences. Okay. So in designing an optimal tax system, there's a whole bunch of issues you have to consider. You have to think about whether you should tax income, tax consumption, tax capital income, how to redistribute the money collected, through what means. You know, is it just you give people cash back, or do you build roads and bridges that people can use, or give them health care? There's issues of what deductions do you allow people to take. That's been a big fight in Congress recently. Should you have targeted deductions, or should everyone get the same deductions? Should there be inheritance taxes? How many different brackets should you have, and at what incomes should they start? What sort of administrative process should you have? How should you monitor that people are actually paying their taxes? What programs should the government spend on? There's stuff about subsidizing people to work. So in fact, you can get paid by the government if you earn a certain amount of income because they want to get you into the workforce, right? So that's another issue. So all of these issues are important, but I'm going to focus on two that have really been at the top of the news and of the economics agenda, which is sort of on average, what sort of tax rate should people be paying? And is there an extra high tax that the super rich should be paying? So should we have progressive taxes at the very top, or should we have like a flat tax? Okay. So, Andy, why, given that the poor value the money more than the rich, should we, in the standard economic logic, not just tax away all the wealth of the rich and give it all to the poor?
Because the more you tax someone's income, the less incentive they have to work for and earn that income in the first place.
Exactly.
So if you tax it too excessively, then like your revenues can go down.
Exactly. So beyond some point, taxes are actually counterproductive, right? Because if I start charging taxes at too high of a rate, then actually the amount that I receive might go down because the amount that people work is going to go down by so much and reduce the amount of taxes that I'm earning, right? It's sort of like the monopoly problem. It's like I don't want to charge too high of a price if I'm a monopoly because at some point that actually reduces my revenue, right? So if you are trying to maximize average utility, then, so the way we're going to try to look at this issue is we're going to try to maximize average utility given a few things. First of all, I'm going to only allow you to have a linear income tax and then a special surcharge on the rich, say over $1 million, right? And you know that if you raise taxes, people are going to work less because of the substitution effect. People are going to take more leisure, work less. And all revenue that we raise is going to be given back as a lump sum to the whole population, not targeted in any particular group, right? And for simplicity, I'm going to ignore income effects of those lump sum transfers. It might be that if you give people a lump sum transfer, they're not going to work as hard because now they don't need to work in order to get a basic subsistence living. I'm going to ignore that issue, right? Okay. In particular, Emmanuel Saez, when he studied this, found that it doesn't matter very much, given the estimates we have of income elasticities, so it's just not worth including. So the key force then is going to be the reduction in work caused by the labor supply elasticity. That is, the percent reduction in the amount that people work when wages fall by 1%, right? And I want to call the average elasticity of people who earn income I, EI bar. right? That's on average, if you were to reduce the wages of someone currently earning an income I by 1%, how much would they reduce the amount that they earn? Now, if we have a linear tax, right, then we're going to, people's after-tax income is going to be 1 minus the taxes times their income, because that's how much they get to keep. But then we also tax everybody amount T, and we multiply that by the average income, because that's what everybody gets back as a lump sum. Okay. So the post-tax wage that people earn is their pre-tax wage times 1 minus the tax, right? And what percent does a 1 unit rise in the tax cause people's, the average earnings of people to fall by? Terrence? Where's Terrence? Oh, not here? Okay. Well, we want to know what's the derivative of your post-tax wage. Sorry, what's the derivative of, okay, so we want to know when the tax rises by a little bit, how much does that change the effective wage that you're getting, right? Because we know the elasticity of people's income with respect to the wage, right? It's just the average elasticity that we wrote down there. So we need to figure out how much do people's post-tax wages, their effective wages, fall when we increase taxes, divided by that amount, because that's the relevant wage rate, right? So that's the percent by which your post-tax wages fell. Okay, so taking the derivative of this, we get negative W, and then divided by W times 1 minus T. And so we get negative 1 over 1 minus T. So if we increase taxes, average income is going to fall by the average of income times the average elasticity at that income, divided by 1 minus the tax rate. And then we have to divide that by the total income in the population, which is just the average value of the income. So that gives us that the percent by which average income falls when the tax increases is the average elasticity, where the average elasticity is weighted across incomes by the income at that level. So we put more weight on higher income people, divided by 1 minus the tax rate. Okay. So this is an income-weighted average labor supply elasticity. Yeah, go ahead, Bob.
Should we also include the fact that people, sort of, I guess, at the bottom bracket, work less now because they have more money and don't no longer need to work?
Yeah, I said we're ignoring that income effect. Emmanuel Sayes found it's not that important for this sort of a calculation, so we're just going to ignore it. Intuitively, that's going to most affect people who are at the very bottom of the income distribution, and them earning less doesn't have much effect on anything. So, okay. So we're going to ignore the income effect, as I just said, and then we're going to evaluate total welfare. So what's total welfare? It's the integral over all incomes of the post-tax, of the logarithm of the post-tax wages people earn, times the density of people earning that income, right? And by the envelope theorem, right, every individual is going to choose the amount of leisure that they take so that they're just, so that any change induced by a change in taxes to the amount of leisure they take doesn't matter for their welfare to the first order, right? So we can just ignore their decision about how much income to earn. And so the derivative of their personal income with respect to a change in the taxes is just going to be the difference between the income tax they pay and the transfer they get back. So basically, it's going to be the change in the tax rate times the difference between their income and the average income in the population, which is very intuitive. People earning above average income will be happy when there's lower taxes. People below the average income are going to be happy when there's higher taxes. Okay. So taking the derivative here, we get that the top of this, there's two effects. On the one hand, as the taxes go up, I lose my income. But on the other hand, I gain the average income minus however much the average income changes because of this elasticity effect when the tax rate goes up. So that's equal to the tax rate times how much the average income changes, which is the average income times the elasticity divided by 1 minus t from our derivation above. Then we have, by the chain rule, we need the derivative of the logarithm, which is just 1 over the income of those people. So this says we're going to integrate over everybody this, which is the effect on their personal income of a change in taxes, multiplied by 1 over their income, which is how much we care about giving money to that person. So that gives us this formula, which is the 1 minus the tax times the average elasticity over 1 minus tax times the average income times the average value of 1 over people's income. That's called the welfare weight, because that's how much we value giving $1 extra to that person. Minus the average value of the welfare weight multiplied by the income, which is I times W bar. Okay. Now remember that the difference between the product of an average and the average of the product is, from what we before said, the covariance, right? And let me normalize the covariance by dividing by the average income and dividing by the average welfare weight. So that's like a normalized covariance. And let's call the negative normalized covariance sigma. Now, why negative? Well, people who are rich, we're going to care less about giving money to them. And people who are poor, we're going to care more about giving money to them, right? So this covariance is always going to be negative between people's income and the welfare weight, right? And so we'll call negative this covariance sigma of the tax rate. Okay. So what does that tell us? If we just rearrange this equation, we get that 1 minus the tax rate times the average elasticity is equal to 1 over 1 minus the tax rate is equal to to this covariance thing that we have. And so just rearranging that, we get that the tax rate is equal to this covariance divided by the average elasticity plus the covariance. Okay. Okay, so notice that the optimal tax will increase if sigma increases and will decrease if epsilon increases, right? Now, David Wang, how does that capture the basic trade-off that we were talking about before between trying to reduce income inequality, but on the other hand, that having the cost of reducing the work that people do?
So I think the sigma t is the inequality. So that means
Why intuitively does it measure inequality?
because it's the because the welfare have a lower welfare weight.
Yeah?
Therefore, as t is decreasing, there's an increase in inequality.
Yeah? So think about, why is it the case, what would happen if everyone had the same income? What would this sigma be equal to?
Sigma would be equal to 0.
Yeah, because there's no covariance between things that don't vary at all, right? The more they vary, the more that we're getting situations where some people are wealthy and have a low welfare weight, other people are poor and have a high welfare weight. So that's creating spread in this, that's creating a large value for that covariance, right? Okay. And how about the elasticity?